In this scenario, we have a block starting from rest. So here's our block. V0 equals 0. Is pushed with a constant force across the track. So there's a force applied in that direction. We have our position time. What is the magnitude of the change in momentum? Between 0 and the first 4 seconds. So 0 seconds to 4 seconds. So we're looking for the total change in momentum. Well, the change in momentum is m delta v. And we know the mass has a 2 kilogram mass, and that's not going to change. Well, what is the change in velocity? We know the change in velocity is v minus v0, and v0 is 0. So what is that instantaneous velocity? Well, we could do some fairly quick calculations to find out the average velocity during the interval. And so this is a change in position of 0.1 over 1. So that is 0.1 meters per second. And in this interval of time, we have a change in position of 0.3 that occurs over 1 second. So that new velocity is 0.3. And the interval here, we have 0.5 over 1 second. So the velocity is 0.5. And we have 1.9 to 0.6, which is 0.7 over 1. So 0.7 meters per second. So we know that the average velocity in that interval is 0.7, so the final velocity must be greater than 0.7. So that final instantaneous velocity must be greater than 0.7, because that's the average during the interval. And remember, if the velocity is increasing, what we've done is just calculated an average of 0.7. And the previous interval, the average was 0.5. All right, so the change in velocity, at the least, this change in momentum must be at least 2 times 0.7, which is 1.4. So right away, we can eliminate this and this as possibilities. We can eliminate those two as possibilities because they are less than 1.4. And we know the answer must be greater than 1.4. Now, this 3.2 is more than 2 times this value. So that suggests this value is unreasonably large, and we could reasonably estimate that that's what's going on there. But we could also do another calculation. We could start out with x equals 1/2 at squared plus v0t plus xo. And we know the initial velocity is 0, and the initial position is 0. So what we have is a final position of 1.6. We don't know the acceleration, but we know the time is 4. So we have 3.2 equals a times 16, and a then is 3.2 over 16, which is 0.2 meters per second squared. And that actually matches 0.2, 0.2, 0.2. So if we have v equals at plus v0, we have an acceleration of 0.2, 4 seconds, then we would expect the velocity to be 0.8. So if it's 2 times 0.8, well, that would be 1.6. Now notice we didn't actually have to go through a calculation. We knew it had to be larger than these two. This one was unreasonably large. It was more than twice the value we had gotten in it, whereas it should have been just a little bit larger, and that little bit larger is 1.